Thank you for coming. So we're here today to talk about laboratory safety at Roxbury Community College. And so you might ask, well, why do we go over laboratory safety? And laboratory safety, one, is a requirement, so that's one of the reasons we go over it. It's required by the state and federal governments. But in addition to that, it's just for the betterment not only of you, but your students and everybody else here at the university, at the college. So the safety breaks down into 5 basic elements. The first one is general training. So what I mean by general training is this is the training that would be required for anyone in any particular course. So whether you're teaching chemistry, microbiology, physics, general science, these are things you should always know when you're working in a laboratory space. Now it doesn't mean that everything that's in general training will be applicable to what you're doing in your lab space, but this is something that everybody should in general know about. Now that brings me to the specific training. This is something that would be important for you in your particular position. This is not something that I will be going into detail of here in this talk. Specific training would be something that if you have a particular piece of equipment or you do a particular type of experiment that's very unique to your area, that's the one that you would then come to me, ask me if you want to create, say, new safety protocols on, or to go over what the training would be for that. Then there's there's safety training compared to general training. So safety training in this case is the things you need to do to be safe in any laboratory space. So this is not general training, but the actual type of equipment that you need to wear, how you need to conduct yourself within that laboratory space. Things that are applicable specifically here, for instance, at Roxbury Community College that we want to make sure are implemented. Then there's always an aspect of security training that people always fail to think about. Now, when you're working in a laboratory, security is important for many reasons. One, you don't want random people to be able to just walk in and hurt themselves, but there's also always the risk of somebody coming in and on purpose, say, to take something, steal something. Obviously, we're sitting here, these computers are for the most part bolted down, and the same thing in the laboratory. We work with chemicals, things that if in the wrong hands could be potentially dangerous to someone. And we have to order them through specific regulations. We have to have permits in order to get them, and we don't want people to just be able to wander throughout the labs. So we'll get into a bit of security training. And then on top of that, in all cases of training, you need some sort of testing. This will just show whether or not you've understood the material and whether you're okay to work in the lab space. And this will certify you for 1 year from the date of your training and testing. So to get started, general training. General training will go over the kinds of hazards that are present in the laboratory space. And by hazards, there are 9 different classes. And some materials can fall into more than one class. So as you're going to find out from this particular talk, there are hazards such as flammables, corrosives, oxidizers, and it doesn't mean that just because something is marked as flammable that it's not, say, corrosive or it's not toxic. A lot of these hazards can fall into multiple classes, but they tend to have one particular class that stands out more than others. So in the case of flammables, that's one of the classes that you always have to consider. If you're talking about oxidizers and, say, toxic items, typically the oxidizer would take precedence over the toxicity. So, class number 1, explosives. It would be indicated by this orange symbol here. It will have the number to indicate the class that it belongs to. So all the classes will be indicated by the number they correspond to. So in this case, 1. Or they'll sometimes see signs such as this, danger explosives. Either one would do. And so these are any devices or chemicals that are designed to function in an exploding capacity. In general, we don't have too many of those here at RCC, but as I said, you would want to keep an eye out for the labels. Class 2 are gases. So there are 3 different types of subcategories for gases, and as I explained before, the symbol number 2 will appear at the bottom regardless of whichever tag for the different categories. So you have flammable gases, which is indicated in a red tag, poisonous gases or non-flammable poisonous gases, and they'll also have an LC value on it. So basically this stands for lethal concentration 50. This means at a specific concentration, half of the subject, so in this case it was typically mice, died at that particular level of exposure. So that would indicate a level that you want to keep in mind when you're working with those kind of gases. And then you have your non-flammable, non-toxics, which are indicated by the green label. This is the kind of label that you would find on, say, a CO2 tank. Now, the types of gases we use here at RCC are things like CO2. You'll find them up in the tissue culture room. But the one that's probably most often used, but least considered about, is the methane, which is the gas that we use at the bench. This gas obviously has a certain smell to it, so you know whether or not it's in the air and whether there might be a leak. But this is also one that I need the faculty to pay close attention to, because there's not only the student shut-off valves that we need to make sure that the students close after every class that they use it, or after every time they use it, but there's also the main shut-off valve in the hallway, typically outside the classroom. And it's the responsibility of the faculty not only to call, say, the security or a technician to turn that on for them, but to make sure that that's turned off after the class. We want to make sure that nobody can just come in randomly to the lab space and, say, play with one of the gas valves on the desk and have gas coming in. Class 3 are flammable liquids. So flammables in general are always represented by the color red. Remember, with the flammable gas, that was the red tag before. They have the 3 for their class numbering. So there's different groupings of flammables based upon their vaporization point, so their flash point. For instance, flammable liquids would be considered something that below 140 degrees would ignite, but a combustible liquid would be something below, say, 200 degrees that would ignite. Regardless of whether it's a combustible liquid or a flammable liquid, these are ones that we need to be careful of. They tend to get isolated, so we put them in a safety cabinet, the flammables cabinet. This type of cabinet is the one that we use in our waste facility here at RCC, but it's not the ones that you would see in the lab spaces. Here at RCC, we have flammable cabinets that are actually situated underneath the hoods. And I want you to be careful of this, because in this case, both sides here in the picture act as a flammables cabinet. At RCC, we happen to have them divided. We have a chemical cabinet, or I should say half a chemical cabinet, half a flammables cabinet. So one side is wooden and one side is metal. Only the metal side actually is rated for flammability. The wooden side is actually a chemical cabinet, which you would not want to put any flammable items in. And some examples of the flammable liquids that we use here are things like isopropanol, ethanol, acetone. These are commonly used in the labs. And we need to make sure that they're used appropriately as well as collected afterwards. All right, class 4 are flammable solids. They'll also be indicated by red, but they'll have the red stripe symbol. These are substances that are thermally unstable, and they can spontaneously ignite on their own when exposed to either air or water. And if it's water, they will typically have a separate type of signal which will indicate, for instance here, dangerous when wet. Now here at RCC, we don't have too many of these. The only one that I can think of that is used relatively frequently or yearly in the labs are the magnesium strips and ribbons that we use. And these things, like I said, they are flammable solid. They need to be handled appropriately. The waste from them cannot just be left lying out in the hood. We actually have to collect this and store it in oil, and the oil will keep it from, in theory, igniting. Things like nitrocellulose are also potentially flammable solids. However, personally, I've never actually seen nitrocellulose suddenly combust, but it is technically rated as well. All right, class 5, oxidizers. So these are now getting into things that we're going to more often use in terms of chemicals. Oxidizers are substances that may, by yielding oxygen, cause or enhance the combustion of other materials. So in that particular case, you need to keep it away from anything that's flammable. The flammables in our waste facility are kept in a flammables cabinet. The oxidizers are kept about as far away from that as possible, and they're isolated into their own separate bins. And they would be indicated by the yellow symbol, as you can see here. You have certain subclasses of them, but the number 5 at least will indicate whether or not it's an oxidizer. And some of the oxidizers we use at RCC are things like hydrogen peroxide, permanganate, iodine, but at the concentrations we are using, while they are technically still an oxidizer, they're not as dangerous. I think, for instance, most of the labs will only use hydrogen peroxide at, say, 3%, which is not particularly dangerous. In fact, you can buy those in the store at that percentage. Okay, class 6. These are poisons, substances that are associated with lethality. So if you remember before I mentioned LD, you might also see an LC value, LD50 or an LC50. This either stands for lethal dose or lethal concentration 50. As I said, these are concentrations that at which point 50% of the subjects that they tested would die. So what this means is that just because something is poison is a poison, it doesn't mean that that substance is poisonous at the concentration you're using it at. If it's considerably dilute, so for instance, for a vapor, you can have 5,000 parts per million. If you're using a vapor that's, say, 1 part per million, it's considerably below the lethal dose level, and in theory would not be something to be as worried about. Now, that doesn't mean that you shouldn't use proper precautions when working with poisons, but keeping in mind the concentration of the poison is important to know how dangerous it is for you. And things like medical waste also can fall into the category of poisons. So examples of poisonous substances we use here are things as simple as disinfectants. At certain concentrations, disinfectants that we use, say like the ones the custodial staff use, can be poisonous. Other things that we use in the lab space that are highly toxic are things like, say, sodium azide. That's why we isolate them. We not only keep them inside their primary container, but we store them in a secondary container as well. Okay. Class 7, radioactive materials. So these are radioactive nucleotides that exist over specific limits. So remember, radioactive nucleotides do exist naturally in the environment, but these are substances that have been enriched in radionucleotides. They can come in the form of solids as well as liquids. They can be used for research purposes as well as medical purposes. And this is a very unique category because unlike the others that you could potentially leave sitting there for a long period of time, radionucleotides have a half-life. So something like P32 has a half-life of 13 days, meaning that if I take my stock of P32 today, which I have to stand behind a plexiglass shield, use gloves, use my lab coat, and I leave that sitting on the desk for, say, 6 months, suddenly I can come up to it and most likely just pick it up with my hand, I can throw it out in the garbage. And that's typically what a lot of facilities do. Depending on the half-life of their radioactive substances, they store it on site, and then they dispose of it themselves without having to go through any legal means. Now, that said, RCC does not use any radioactive substances in our science laboratories. And I specify science laboratories because some students here at RCC may have to deal with this later in the nursing program because they use it for diagnostic purposes there. But at least in the science labs, we don't. Class 8 hazard is corrosive substances. So these are substances that at a specific amount and in time will destroy human skin. So these include both acids and bases, and some corrosives are incompatible with each other, so you need to keep them isolated, and you don't want to necessarily mix them. Things that are also of concern is that corrosives can affect steel and aluminum. So these are examples of metal corrosion, but keep in mind, they could do the exact same thing to human skin. And one of the reasons I point out steel and aluminum is that we want to be careful of what kind of things we store corrosives in. So in general, all of our corrosive waste will be stored in glass, it can be stored in plastic, but this is an example where you would not want to be putting it inside, say, a secondary metal container. You would want to make sure that the containers are not ones that can be damaged by the corrosion, by the corrosive material. And that brings me to the last class, class 9, and this is miscellaneous substances. So these are substances that present a hazard but are not actually covered by any of the other categories. So one that I always like to bring up, and it's commonly used in the lab, is something like dry ice. Dry ice is hazardous. If you hold it up against your skin, it will cause a burn to your skin and it will hurt your skin, but it's actually caused by more of the physical aspects, that it's so cold that it actually freezes the skin. In addition to that, it releases CO2, which you don't want to breathe in too much CO2. Technically speaking, if you were to contain dry ice inside a sealed container, because of the sublimation and the increase in pressure, it would actually cause an explosion. That's why when they ship things on dry ice, they need to appropriately label it, and there has to be a certain amount of venting. It can't be a completely sealed container. But that said, dry ice on its own does not represent any of the previous hazards. It's not really classified as an explosive. It's not a corrosive which damages your skin. So other things are stuff like sulfur. The lithium that's found in batteries and hazardous waste, technically, can fall under the category of miscellaneous. So some things we would consider hazard or bio-waste, but it's not necessarily poisonous. You still don't want to expose yourself to it. Now, the next category that I bring up are carcinogens. A lot of people feel that carcinogens are a hazard class. This is not actually true. Carcinogens are basically just substances that are known or believed to cause cancer. And if you ever look at labels, you'll see that, for instance, they'll often say, in the state of California, this is believed to cause cancer, and so on. Those are carcinogens. And there's a scale of how much something is considered to be a carcinogen, how likely is it to cause cancer. Now, that said, this is not a hazard class. There are actually many examples of things that fall into the other hazard classes, but are still carcinogens. So it basically can spread across all the different classes. So things like, say, ethidium bromide, which intercalates into DNA, is toxic. It's also a carcinogen, but so this is class 6. Formaldehyde is flammable, but it's also a carcinogen, so it's class 3. Things like X-ray and gamma radiation, which radiation is often considered to cause cancer, it's a carcinogen, but this is also class 7. And then things like asbestos, which people were very concerned for about 20, 30 years ago, removing it from houses and such. They believed that it would cause cancer. It technically doesn't fall into any of the hazard classes. So this is an example of a miscellaneous class item, or class 9.